show more detail. So I'll go into what does that look like. I don't want you to have to draw this and do all that and count those. You know why? Because it's really problematic. It's really hard to do that to scale. So instead, when we get to a graphing problem and you don't have graph paper, if you do, great. If you don't, it's totally fine. I think it's going to be better in the long run for you to do it. Go ahead and draw your axes. Which is which?
X is the one going across, and Y is the...
X is horizontal, Y is vertical. Just plot your point in the correct quadrant. They're called quadrants because there's 4 options. And then label the point. So based on whatever I was told about that particular problem, I can label the point. I don't need to do the little check marks now because I know that it's right 2 units and up 3 units. And likewise over here, I can come over here and put on that one, I can do -3, 1 or something like that. That would be enough. And if it was talking about a line, I'll get out my tools here. If it was talking about a line, then just connect them, right? That is going to be perfectly sufficient, and it's accurate. Why is it accurate? Because as we're going to talk about today and for the rest of your high school math career, what else is coming, it only takes 2 points to define a line. Because a line has a certain characteristic about it.
It never ends.
That's true, so it has infinite points, but why does it only take 2 points to connect a line? Or to define a line that would be different than another line? It only takes 2 points. You know why? How about I ask a deeper, seemingly weirder question? Okay, prepare your minds for this. What makes a line straight?
The way you draw it.
That's a pleasant noise. What makes a line straight?
The way you draw it.
The way you draw it. Why do we draw it straight? Think about what a line represents, or what you're going to learn that a line represents. A line represents a relationship between X and Y.
Single.
A relationship between X and Y. A relationship that does not change, but is constant. That's theological if you think about it. Who never changes?
God.
God never changes. His love for you never changes. A line is straight because the relationship between X and Y. I'm not making this stuff up, right? It never changes. It's called a rate of change. Are you laughing that I'm interjecting here? All right. Anyways, that's all right. That's not what was asked about number 1 or number 23, though. I don't believe. So let me hit those really briefly. I'm going to do 23 first. And 23, you got a whole bunch of this. Parentheses, and they seem to kind of go through all the possible choices. 1, 2, 3, 4, 5. And then you're just going to copy them over here in the order that they appeared. Where you have 3 choices there, parentheses, bracket, curly brace, and then it starts over. It's like a pattern. Anyways, they're just there to separate things. Honestly, if it was just a whole bunch of parentheses, it would mean the same thing. It's just easier to keep up with it when you use different symbols. But you kind of work your way inside out here. There's two ways of thinking. Work your way inside out. So that's -9. What would happen then?
Positive 9. Positive 9.
-9 now. It's going to alternate. So this is -9, +9, -9, +9, -9. So the answer would be -9. I'm pretty sure I saw a lot of positive 9s on your paper, so go back and make sure you fix that. The second way that I taught you to do this was because one negative cancels out another negative, there's a pair-like relationship there. So for every couple, they cancel out. Said another way, if there's an even number of symbols, it's positive. Each one will have a match to cancel it out, so to speak. If there's an odd number, like there is here, then the output, the answer will be negative. Okay? Number 1 was the problem about the Braves started the season hitting 1.375 times their season average for the previous year. I'm going to go ahead and say times A. If their season average for the previous year was 0.368, what was their beginning average this season? So we're going to say that's the new. They said if the season average for the previous year was 0.368, which is what A stood for, then we're just multiplying 1.375 times 0.368. So first of all, is that going to increase their average or decrease their average based on this number? Why? Now this is their average. This is the multiplier. The multiplier is 1.375. Because that number is larger than 1, it's going to cause an increase. Yeah, we will just type this in the calculator and see what we get. If I can get it to clear. 1.375 times 0.368. 368 is a pretty good hitting percentage, right? Batting average? So 506. They were all hitting 506. That's really good. Baseball folks. 506 as a batting average? Yeah, okay. All right. Were there any more that you guys thought of before we move along to this challenge that I've been speaking about? Any more? We're going to come back. We're going to do graphing. So if it's on graphing, you can hold that thought. 4 problems, and you have 4 representations for all of these. Okay, representations like an equation, a table, a description or word problem, and the picture of that. So the way it works, they're going to be grouped together, right? So one equation goes with one table, which matches one description and one graph. Hypothetically speaking, let's just say, okay, maybe you find out that equation 1 goes with table B and letter L. It matches up, and it's graph H or something like that. Okay, so your job, and I really should have printed these on 2 pieces of paper so that you could look at them at the same time, so that's my fault. I'll just leave this one up here. Your job is to figure out what matches. Okay, look for relationships that you should know, like how do you match a table to an equation? What's going on there? And then we'll expand that to, okay, let's see, how does that line up with one of these scenarios? Okay? So this is an opportunity for you to see how it's useful and make some deeper connections for the purpose of learning this, both the rest of this year and in Algebra 1. Okay? Let me go back over what I was speaking to Jeremiah about. So he made a great point that here lies the point 0, 1. And he matched graph E with number 3. Graph E. Because the point 0, 1 was on there, and I could connect the dots to table A. But then he said, well, 1, 3 though. 1, 3, I'm not seeing it on graph E. And he was looking over 1 and up 3. And many of you may be doing the same thing without realizing each box in this direction is not 1 unit. How do you tell? Because it says this line, that's 2.5. So if that's 2.5, that took 5 boxes. It takes 5 more to get to 5. 10 boxes get to 5. That means each box is only worth a half a unit. So the point 1, 3 would actually be here. That's 1, that's 2, 3, 4, and 5. You see, the scale of a graph can change based on whatever is supposed to be displayed. Okay? So pay close attention to that. Moving forward. So, again, this is something that you'll come back to and be able to make connections between, hey, how do we graph a situation like this to be able to answer problems? So that will be the goal for next year. I just wanted to give you some exposure to it today. This is not going to be on your upcoming test. Okay, you will have to make connections between things like this, but you don't have to do the description. Okay? So, 0, 1, 1, 3, all of those satisfy equation 3. So that's A. And then we just need to pick a description. So, Jeffrey, you said you were working on descriptions. What'd you get? Did you find one that matches up with number 3?
For number 3.
2x plus 1. Y equals 2x plus 1.
I just
Didn't get one? That's okay. Did anybody get a description that they think matches up with what's going on in equation 3? K. Why do you think so, Mead?
Because it says the cost of the fare is $1 and $2 per ride.
Okay, so one of those is a constant. One of those changes based on how many rides. So if you look at this structure here, the 1 will always be 1. It can't change. But 2x can change because x is a... What was that word, Maddie? What was that word for x? Well, it's not a solution yet, but it was just a letter. It's unknown, we call it. It's a variable. It's able to...
vary.
Yeah, so that's right. K is what we want to go with. All right? Got that one. Got that one. Next. So y equals x minus 3. Who got the table for equation 1? X minus 3. Morgan, was that you? Did you get that one? The equation for... What's the table that goes with that one? B. Now, she specifically told me, hey, when you plug in negative 2 for x, and you subtract 3, you get negative 5 for y. And that's correct. What I want to make sure everybody understands is, hey, just to be safe, you should check a second point. Okay, because it's possible, like you see on the whiteboard, that lines can have a common point and be totally different lines. So if we check 5, 2 here, plug in 5, 5 minus 3, is that 2? Yes, it is. Okay, B. All right, now y equals x minus 3. Which situation did you guys see matches up with that? J. No matter what time I tell her, Grandma always shows up 3 hours early. Is that funny or no? Okay. So if you tell her 5 p.m., what time is she going to get there?
She's going to get there at 8, bro.
2. She's early, not late.
Oh, okay.
So it's J, B, and J. Now x minus 3. You see the points here that we're matching up. All we've got to do is identify where are those points on the graph. So which graph has those points? I believe it's right here at H, because that's 5, 2. This is 0, negative 3, right there. 0 minus 3. And there it is. Whatever time you tell her, take 3 hours away from it. So it's graph H. So we got H. We have table... Oops, not H there. Sorry. And H. Okay. X plus 4. So... Anybody get the equation that matches, or the table that matches x plus 4? It's not A or B. D. All right, how do you test it, Mead?
So negative 4 plus 4 is 0. And that all adds up.
Okay. Sorry, I thought somebody was blowing their nose. That's a hammer drill. So, and then we could test 1, 5, right? 1 plus 4, yep, that's 5. 0 plus 4, yep, that's 4. They all have to match, otherwise it's not true. But you only have to test 2 to make a decision. So table D, okay, we got Grandma taken care of. The depth of my fish finder is most efficient when placed 4 feet below half of the water's depth. Sorry, that is a little loud. When you guys read the descriptions, the last 2, which one seems to match up with y equals x plus 4? You see, the fish finder problem says 4 feet below. So that's kind of an indicator that, hey, I don't think that's going to be right. Whenever Mom tells us dinner will be ready in such and such minutes, it always takes 4 additional minutes. 4 additional. You see that lesson previously on clue words that tell you what to do, what operation, product, sum, more than. That's kind of helpful here when you start reading descriptions too. 4 additional. There's the plus 4 right there. So this one's going to be M. And then who can tell me what graph matches up with y equals x plus 4? Y equals x plus 4. there were some patterns I told a couple groups to look for. Y equals x plus 4 is going to be this one, and I want to draw your attention to the point 0, 4. Okay? So it's going to be F. And of course we got 1, 5 there. All the other points are going to match up. So that's F. F. So that means we're left with this one. Y equals 1/2 x minus 4. Now, just to stop for a second, slow down just for a minute. What's different about that equation compared to the other three?
Fraction.
What is the fraction doing? Like, what is the job of the fraction in that problem?
Division.
It's division, yes. The fraction is attached to the variable. Whereas all the other variables, all the other x's, so to speak, they had a whole number beside them?
Yeah.
Wait a minute. It just says y equals x plus 4. How can you say there's a whole number beside y equals x plus 4? Is there something understood to be right here beside of this x?
2.
How many x's do you see?
Or 1.
So there is a coefficient understood beside the x that's always 1. Okay? We'll learn the significance of that maybe in a future math class. Okay? But we know that this is going to be L. That's the only one that's left. We know that it's going to be table C. We can check it, right? 0 minus 4. 0 minus 4. There it is. 8, 0. 8 divided by 2 is 4. 4 minus 4. Yep, that's 0. It works. Only have to check 2. Don't have to worry about that one. The depth of my fish finder. 4 feet below half the water's depth. So right there, that half the water's depth, that's my 1/2, right? So you'll notice that this one seemed to go up. It's a little less steep. It's a little less steep than the others. Does it look that way to you?
Yeah.
Man, that's... So G. So this is what you had to look forward to. Matching up these representations, okay? What I want to make sure you guys are aware of relative to the homework questions that I saw on graphs, you only need to be able to make these connections in the graph. You don't have to do this yet. I might ask that for extra credit, but the way we make these connections is that these pairs of numbers, what do they do to these equations? Do you remember the verbs, the words we used? These points represent what for the equations? If they solve the problem, they are solutions. They make the equation true or satisfied. A true statement like 4 equals 4 can only be had whenever the solutions are placed in there. Okay, so we're evaluating these to see if they are solutions. Okay, so for the rest of today, if you guys will kind of stash that in your notebook, maybe in the back somewhere, depending on how much room you have left, I want to take a few minutes and talk about Lesson 88. The problems that you do tomorrow are only in Lesson 88. Doesn't mean we're not doing Lesson 87. It just means I want you to read over 5 properties in Lesson 87. Okay, so don't neglect to read through those. They're not problems in and of themselves, but they are ways you can solve problems. Okay, so let me give you a really quick example, just so that I don't completely skip over it. Okay, if A equals B plus 2 and B equals 7 plus 3, okay, then what are we allowed to do? How can we find out what A is? If we know that B can be represented as 7 plus 3, then what can we do? Because B appears in this expression, we can replace it here. Okay, so this is one example of... This is kind of like the transitive property, okay? Well, let me give you another example. Right, all we would do here is say, well, A is equal to 7 plus 3 plus 2, right? Or A would be 12, like that. A more general representation would be if A equals B and B equals C, What is true if A equals B and B equals C that is not stated yet? What must be true if A equals B and B equals C? Having a hard time with that one?
A equals C.
Yes. A must equal C. Okay, if A is the same as B, or B is the same as C, we can then state, therefore, A must also be C. But lesson 88 is a little less heady, if you will. Lesson 88 is just surface area. Now, we've done area before. You've been doing area for a long time. I think you start area in the 4th or 5th grade. But what if I asked you to find the area of a shape like this? Oh, a cylinder with dimensions, let's call that R, and then obviously the height is H. Do I need anything else? And for this, you'd have to remember how many faces. I mean, not necessarily faces, but how many faces does a cylinder have?
2.
3. What would they be, Ezra? Circle on top, circle on bottom, and then the sides. That's one shape, isn't it? Do you remember how we talked about forming that, though? We're looking at a circle on top, a circle on bottom, and then what comprises the wrap? It's a rectangle. Good, Cole. Okay? So the surface area of something like this cylinder would be as simple as, hey, let's find the area of the top, which is, what is the area of this circle? Got to make flashcards. Area equals pi r squared. Area equals pi r squared. The rectangle. Now, Cole was the one who said, yeah, that's a rectangle, bruh. It has a height, but how long is it? And for that, you have to think, how does the rectangle become the wrap of a cylinder? What does it do? It bends into what form? A circle. So how long does it have to be such that it will bend all the way around the circle? What particular value is that, Ezra?
Width.
No, we don't call it that. We call it, we call it the this is the circumference. So it has a height and it has a circumference. Hey, that's got a formula too, doesn't it? What is it? Oh no, gotta make those flashcards. Don't worry, I'm making Cora do it. So
A equals.
not A, because that's area,
Oh.
but the circumference, which would be this length. Let me just put that here. That's the distance around the circle, otherwise known as perimeter or circumference. That is pi d, or what I want to call 2 pi r. It's the same thing because d is equal to 2r. So the area of the rectangle that Cole said, hey, that's the wrap. What is that? Isn't it just length times width? Using these values. So 2 pi r h. So my total surface area would be pi r squared plus pi r squared. Oh, there's two of them, right? Plus 2 pi r h. Now, that's the only one that you'll see that's got a round thing in it. Ooh, that one's going to be fun. Example 88.2. Pay special attention to that one as you're working through these practice problems.